Morning. This is the beginning of our Sunday sessions. We have Jennifer Martino and Nick Doiron talking about Tech is a Tool, Kids Code to Revitalize Indigenous Nations in Canada, and New Pathways and Communities to Teach Coding. Jennifer?
All right, thank you for the intro. Yeah, so it's great to join you guys again. I don't know how many years this is in a row, and I really wish I could be there. Although Toronto's looking a lot like San Francisco right now. It's absolutely gorgeous. So that makes me feel a little better. Yeah, so I want to talk about something a little different today than we've done for the last few years. Of course, I'll give you an update about what's happening in Canada, but I also want to speak to you about where we're hoping to head in 2017, and it's something that we could really use your help with. So hopefully some people will be interested enough to come on board and give us a hand. So let me just, I guess I have to screen share first. Okay, you see everything okay?
Yeah, that's great.
Okay. All right, so first I'd like you to imagine that you're going on a journey with me today, and we're going to head north. But of course, to a lot of you in the States there, Canada and Toronto is already pretty north. I want you to think a lot further north than that. So if any of you have heard of Canada's provinces and territories, we're going to head to Ross River in the Yukon Territory. Okay. And Ross River is a fairly small community. It's located 4 hours north of Whitehorse. And so from San Francisco, you'd imagine you'd have to fly to Vancouver, and then you'd have to fly from there about 3 hours to Whitehorse, and then you'd have to get in your car and drive another 410 kilometers in order to get to Ross River. And what we find in Ross River is the same thing that I've consistently found in our work with Indigenous communities in Canada. That's caring educators who are working tirelessly to make a difference for their students and for their communities, and extremely bright students. Okay? So I'm not sure how much coverage you get of the Indigenous issues where each of you are located, but in Canada, often the attention can be quite negative, and there aren't as many good news stories as there are bad news stories we find in the media. That's starting to change. There's a much bigger voice. For example, our national broadcaster, Canadian Broadcasting Corporation, has started to have different Indigenous themed shows and podcasts. We also have the Aboriginal People's Television Network, which does a really great job of covering Indigenous issues. We still have a long way to go in terms of the general population's understanding of what's happening in Indigenous communities, and not just some of the crisis situations they're facing, because that is a significant problem, but also how much incredible work is being done by really brilliant people and dedicated people to make sure that the next generation has a brighter future than the current leading generation. Just before I get to this one, sorry here. Okay, so this is the principal in Ross River, and I just wanted to give you a sense of why it is that we work specifically with Indigenous populations in Canada. We get that question a lot. And of course, it's not that they're the only population that can benefit from access to technology, but they are in a unique circumstance when it comes to having adequate funding to provide technology for student use. And without getting into too much detail, we have a provincially funded system, which used to be like your state-funded system, but then Indigenous communities are usually under our federal system, because they're responsible for the obligations that they have to Indigenous communities under what's still called the Indian Act. Okay, so they actually get 33% less funding per student than a child under the provincial jurisdiction. 33% less. And technology isn't even covered under the amount that they get per student because it's considered a capital investment. Same thing as fixing a leak in your roof. and they have a lot of pressing concerns. So that's why I think we've had so many applications. We currently are looking at 220 outstanding applications from communities. And that's, we really need to make a bigger dent in that in 2017. And so here, just to give you some context, the principal of Ross River School is an applicant community, said technology is greatly needed to enhance student success in school. Many students do not own computers, so the use of technology at home is limited. New digital tools can enhance student learning both at school and home. The traditional language can also be delivered through technology if all students have access to computers. Okay. And this is kind of the map to give you an idea of where we get requests from. And you see, I don't know if you see here, this is the Yukon. So I'm here, you're down here, and this is the Yukon, and we're talking about a community like Ross River, right there. All right, let me just here. I'm gonna jump around, do this. I just a little bit differently. Okay, so this principle has mentioned specifically Indigenous languages and using technology as a tool to both preserve and revitalize the languages. Now, this is a big issue in Canada right now, and perhaps you're already aware of that. You might know that the Prince William and Kate Middleton recently made a tour of Canada, and they were really focused on getting to know Indigenous peoples and looking specifically at Indigenous language. And so I had the opportunity to meet the Prince and Kate in the Yukon, and we were looking at a project where they launched, a partner of One Laptop Per Child Canada called Prince's Charities Canada, which is Prince William's charity in Canada, had launched a book in the local First Nation language in Whitehorse. And we provided laptops to each of the students at a family learning center with a digital copy of the book and an accompanying video, which had an elder speaking the language so that the children can follow along, and they can both see her mouth moving to help with their pronunciation, and they can see the words in the book and on the screen. And so this is something that is kind of a movement that's happening in Canada, generally speaking, and there's been increasing interest in it. And it's something that I've wanted to get involved with for a long time, because technology can be such an awesome tool to get youth who might not otherwise be particularly inclined or interested in picking up a language to use it, because it's something that they can put to use, if that makes sense. Oh, sorry. All right. So just to give you just a tiny bit more context about that, that's relevant to what I'm asking you to help with. How do I get here? Okay. So this is a map of Canada and the different Indigenous languages that you'll find. There are over 60 Indigenous languages in our country, and these aren't languages that aren't being used. I mean, these are languages that people are speaking on a daily basis to different extents. So, for example, my partner is from Saugeen First Nation, and his mother grew up fluent in Ojibwe. She spoke Ojibwe with her grandmother who lived in the home. She wasn't able to speak Ojibwe with her children or with her grandchildren, and so unless her grandchildren and her children start to pick it up, then the language will be lost in her generation. And that's something that is pretty standard, and you'll find in communities all across the nation. So they're from this area right here. Okay. All right, so what we're hoping that you'll help us with is our next stop along the journey here in Canada is to use technology as a tool to get youth excited about their language, to start using it for practical purposes. And because, of course, the purpose of a language is to interact with other people, and it can be a survival tool. I know when I took my first trip outside of Canada, I didn't speak a word of Spanish, and I lived with a family that didn't speak any English. And if I didn't learn how to say fork, I wasn't going to eat dinner. So within 3 weeks, I did a radio interview in Spanish, and that was something that would have taken me years in a classroom context. So maybe I'll just So I do also have a kind of a personal experience in connection to this. Stop my screen share here. Okay. So what our next step is to use Scratch, because it comes preloaded, of course, on the XO. It can also be used in app form and on the new one laptop per child laptop. And I wish I had it here to show you. We're still waiting on our first shipment. We'll be getting about 150 of them in the next few weeks. And it runs the operating system Endless. And I know that you have some people from Endless at the conference, I believe. Is that correct?
Yes.
And so so you'll be learning more about that. And they've made the wise decision to include Scratch within the Endless operating system. And then, of course, it can also be used on any Windows platform or Mac platform that they happen to already have in the school. So our challenge to children will be, we know that you're into gaming. And of course, we've all learned through our years of experience with Laptop per Child that the most effective learning comes when children are able to construct knowledge rather than just consume it. And so we want to harness the awesome skills that they have in adapting to technology and creating beautiful and exciting things with it, and then also pair them up with the traditional knowledge keepers from the community, so that there's an exchange of knowledge happening. And you take the strengths of both groups, and they can work together to create animations and games in Scratch that incorporate the local language and culture. And I believe it looks like we're going to be doing about 5 of these workshops in different communities with different languages over the winter. Now, Scratch is a pretty flexible platform. And so I think it's a good tool, and it's something that I've been using for a long time in my work with one laptop per child. But when we're looking at the images and the sound files that come preloaded, there isn't a lot there that is particular to the Indigenous context. So there are some things, although there are 60 different languages and we have very diverse communities, there is no one Indigenous community. There is no one First Nation community in Canada. These are separate nations that share the commonality of being Indigenous to our land. But there are certain things such as different animals or food groups that a lot of people use, like corn and rice and things like that would be very helpful to have in the form of clip art. The other thing is that there are a lot of audio files that are available in different Indigenous languages. So, for example, I know that there's an entire Ojibwe dictionary, and they provided the audio files so you can both see and hear how those words are used. And what we're trying to do is curate as many images and sound files as we can that would be useful and give the kids an advantage and a head start when they go to create their project. Because when you're going into a community, especially with the remoteness of these places, it's hard to spend more than a week with the children. But if we can give them up front a lot of really useful tools to use, beyond, they're also going to be creating their own images and their own audio files and working with the elders and the knowledge keepers to do that. But we'd like to make sure that they at least have some good materials in a folder that they can incorporate as well to save us some time. And the other thing is story starters, to give some kids the early success, and the hope is that they like the program, and once we bring the kids in with the broader community and they're able to show off their projects and hopefully gain some momentum and some additional interest in using technology to preserve language and revitalize language, then they will continue with their own Scratch clubs. I know that Google has done some significant work in creating curricula for Scratch clubs, so we're also looking right now at how can we make it a little simpler to understand for the community so they don't have to spend a lot of time going through all of the curriculum, and then also how can we make things like the story starters relevant to the Indigenous context. So yeah, I wanted to keep it pretty brief and leave some time for discussion and see if anyone has any bright ideas that might help us start off in a good way, as we say here. So I'll hand it over to the crowd.
Hi, Jennifer. This is Tony Anderson.
Hi, Tony.
I'm gathering from your presentation that you're not using sugar.
No, that's not true. We the laptops that we gave out during the royal visit were the XO laptop, and so they're using Scratch through Sugar on those ones.
Okay, but the materials you want built are being built for Endless, and Endless is not supporting Sugar, as I understand it.
No, the materials that we're looking for are image files and audio files that could be used across platforms, so that they'll be useful regardless of whether somebody's using an XO laptop running Sugar, or they're using the new one running Endless, or they're using maybe the school computer lab that could either have Apple machines or Windows machines. And that's the nice thing about Scratch, right? That it comes on multiple platforms.
Right, but what you need is the ability to bring these this media into Scratch and make it available as a Scratch folder.
For the laptops, that would, actually I hadn't thought of that, but yes, that would be advantageous, yeah.
Hi, Jennifer. This is Harriet.
Hi, Harriet.
In what format would you like pictures, and do you have a list of images that you're looking for?
We're working on that right now. I have a person working with me who just graduated from Ontario's Academy of Design in publishing, which is great. So she's a wonderful digital artist, and she's also spent a lot of time going through Google's Scratch curriculum. And so she's currently creating a list of the kind of art and clip art that we're looking for, and also where people could start finding the different audio files. And even things like SoundCloud, I was just on there, and they have just a ton of really awesome content, and a lot of you can download in different Indigenous languages so that children can use the tracks. So we will be providing more guidance and direction, but first wanted to gauge if this is something that people would be interested in helping with. And it's also important because most of the communities we work with still have very limited internet. So their ability to sit down and say, I need X, Y, and Z to make my project successful, and then go online and get it is compromised. It's not the same as sitting in a bigger city and being able to do that. So the more tools we can give them right off the bat, the better their projects will be.
Thank you.
Hey, Jennifer. Super mundane, but everyone asks me, so let me ask you the eternal question. What spec of hardware laptop are you getting from or with Endless for roughly what price? It's the eternal question everyone asks me. I know it's not immediately the topic at hand, but.
Yeah, okay, I can show you. Have you seen what it looks like? I can show you that if you're interested. Where is, oh, here it is. Just 1 second. There it is. So again, I haven't, as I mentioned, I don't have one in my hands yet, so I can't speak to it too much. But at least you can get an idea of what it looks like, and since you're learning more about Endless, you know what it will be like internally. I think in terms of like price point per unit, it depends on the amount that you're ordering. And as I said, we ordered 150 of them, so that's a discussion that we can have offline if you want to talk about that. But I think the best people to ask about that would likely be someone at One Laptop per Child that's selling them. Because it also depends if you're part of a much larger order like we are, or if you're trying to order on your own and things like that. I don't think there's I don't know, but I don't believe that there's like a standard price. I think it's kind of like the XO, where the more you buy, the less expensive it is.
Is OLPC installing the Endless OS for you?
Yes. Yeah. Yeah, it's coming direct from them with it on. Okay.
Jennifer, I have a couple of related questions, not to hardware, but to your question on Scratch. So with Scratch, so you're looking to run it offline, right? As in, it's not coming through the browser, it's actually installed on the machine?
It depends on where we're working. So some of the communities do have reliable internet access, and in those cases, the preference would probably be to do it through a browser, because that way it's easier for them to share their projects and also for us to follow them as they continue their journey and hopefully evolve their skills. We're also aware that the version of Scratch that's on installed in Endless is not the same that you would find online, and that there are some things there like with the vector and the bitmap images and some of the projects that my coworker had created didn't work in the offline environment, but they did work in the online. So that's something that that we're trying to navigate, and we could probably also use help with.
Okay, so that was kind of what I was leading up to, which is that there are different versions of these, and there are some issues with compatibility in terms of how Scratch is, I guess, produced and distributed. And so the next part is in sort of parallel with what Scratch does, which is basically block programming. We also have turtle blocks, which originated, as something that ran offline on the XO, when we first got Sugar way back. But now there is a JavaScript version of that can live both online and offline. Okay. That Walter has been working on, and so some other people. And if you look at how Sugarizer works with both the online and offline model, it's basically the same version of JavaScript HTML5 for turtle blocks that can be made both online and offline. And the block programming concept is similar to Scratch, as in, you drag blocks and sort of make it do something. But there are some other advantages in being able to export from turtle blocks into other scenarios, like exporting to Python and so on. Is there a specific reason to stick only with Scratch, or have you considered both?
No, I mean, we're always open to different platforms. We know that these things evolve. The reason that we were going to start with Scratch is because it's already installed on all of the technology that we provide, I guess, except for the tablets. So it's an easier place for us to start, and especially in places where we might be beginning to upgrade and make an additional donation, but they're still using the original laptops. But of course, there are those compatibility issues between the versions. So it's, that's kind of where we're coming from as a starting point, and also, of course, the fact that it's a platform that I'm quite familiar with. But we would like to learn more about what else is out there, and really, this is just one tool that kids can use to get excited about language and to create their own content around that. But I mean, there's also like Google App Builder. There are a whole bunch of other things that we can start getting into if we can demonstrate some early success with this kind of initiative. So I think the main message is we want to get a lot more into using technology as a tool for skill development and as a way for youth to contribute to the cultural and educational landscape. And to date, we've been fairly focused on providing access, which is also important. I mean, these kids need access to the same technologies that you find in any other classroom in Canada, but there's some more work that can be done there.
Okay. One last part. So in fact, thinking about that, so for instance, if you have a community that is offline and they are unable to get onto the internet, or if it's, intermittent, but it's not very good, the materials that they develop there locally, I'd imagine you would want them to be able to use it right there, rather than waiting for a pipeline where, they get online, they submit it someplace, and then it comes back to them packaged, and then they use it in that community, right? As opposed to the online model where let's say you have a bunch of pictures and sounds, you upload those someplace and then everybody instantly gets it. So that may be an issue to think about, which is especially if you have a community or communities that are largely offline, because then they won't have that circuit to get to a server someplace, upload materials, and be able to get them back installed onto their machines.
Right. Now, in most of these communities, they do have some internet access. So, for example, maybe the principal's computer will be online. And so in those cases, the important thing is that we can't have them relying on internet on their individual device to be able to work on their projects. But it is possible for educators who can either go home or go into certain areas in the school to be able to upload projects and get things back to the kids. As long as they can then put it on their device and they can keep working on it without being online.
Okay. All right.
Hey, Jennifer, one more question from online. Just to clarify, like how the programming in Scratch like revitalizes the Indigenous languages.
Sure. So the push towards preserving these languages so they don't go extinct, a lot of that focus has been on the youth and the role of youth in bringing, it's not that these languages are dead, but you need the young people to be excited about it to bring them to life, you know, and to make sure that they continue forward into the next generation. And what people have consistently found is that getting youth engaged with a language that they can't use in a tangible way is difficult. I mean, that would be difficult for any of us, unless it's a purely academic pursuit, which is not the point in these cases. It's about preserving culture. And being able to both speak with your elders, but also pass on that traditional knowledge, which is not just knowledge of words. It's not like a simple translation from English. It also is an entire worldview that can be lost if people don't take advantage of this time with the speakers before they pass on. And so people have been doing a lot of work with youth and doing things like making movies, you know, making YouTube videos, also creating books, creating ebooks. And so this is just one more way that you can do what they do best, which is take technology and surprise you with it. You know, we found that some of the most popular things that they've done with the XO laptops in the pilot phase of this project is to write poetry, journal, write stories, take pictures, and create beautiful art. And I mean, any of you who've used the XO laptop, it's not the easiest to draw on that. And some of the art that they've made have just been incredible. So this gives them opportunity to kind of combine all of those things that they were already doing, but then also make it interactive. For example, if they make a game, so that hopefully you can get other people who might not be so technologically inclined excited about what the kids are doing, and then also recognizing the tremendous contribution that the elders and the knowledge keepers in the community have by making sure that they work together. So if that makes sense, that's kind of how the whole thing ties together.
Yeah. And these languages, are they spoken and written or just?
Yeah.
Okay, thank you. I think we're close. I think we should hand it off to Nick. Got about 30 minutes left, but thank you so much, Jennifer.
Yeah, thank you. And Nick, I'd love to stay for your presentation. As I mentioned, I do have to drive to another city for a family issue. So thank you everyone for including me again this year. And I do wish I said I could be there with you, but I look forward to continuing this conversation, and let's not make it a once a year thing.
Yeah.
Stay engaged.
You have a short question, Jennifer, before you run? Did you see the film we saw Friday night, this web film? Have you ever seen it?
I wasn't online Friday. No, I don't.
No, in general, have you ever seen it?
It's a few years old.
It's from 2013, 2014. Have you seen it?
I didn't hear the name of it.
Web, W-E-B, as in web, as in World Wide Web. It's a film about OLPC.
In Peru.
And about the very offline community there, and there's a lot of spin within that film. Negroponte says all of humanity will speak one language within 500 years, and we should accept that, to paraphrase.
500 or 1,000.
500 or 1,000 or something years. And, you know, he's not trying to say that we should squelch indigenous languages. He's saying that's the direction the world is moving. I don't know. It's like, it's kind of, the Esperanto dream is about that, right? That humanity can converge around one language. I don't know, maybe.
Well, I guess what
Our model is that everyone speaks Esperanto plus their native language.
Yeah,
Right.
because otherwise, I don't think you would want one worldview. And I don't think that's possible. So hopefully you would have your own worldview. And it's the same in Canada. No one's saying we want everyone to speak just their Indigenous language and not be able to communicate with each other, because that would also mean Indigenous peoples couldn't communicate with each other because we have 60 languages. But the idea is that you don't, I mean, Canada historically has had a policy of assimilation, just like you've had in the United States with immigrant populations. And so we want to recognize that Indigenous languages do encompass a very unique worldview that is valuable. And it is something that we want to invest in and preserve as a nation.
I wonder what some of your communities would say reacting to this film, because the film takes a very interesting fatalistic view, saying that people are trying to run away from many of these communities, sometimes for their own reasons. And how do you balance those tensions? I mean, eternal questions, but yeah.
Never too early in the day for some philosophy, Adam. Thank you. All right.
Great, thank you.
Thanks, everyone. Bye. Bye-bye.
All right.
All right. Thanks to Jennifer for presenting. I'll have to send her an email because I have something in the presentation that would be good to share. Can everyone hear me okay?
Yeah, you're a little muffled.
Okay, let me move the laptop a little closer. Is that better?
A little bit better.
Okay. All right. So I'm going to go through this. If there's some kind of internet connection problem, something like that, please let me know. Okay. So I'm going to be talking about new paths and communities for teaching coding. And I talked about most of this at an event I told the San Francisco group about, JSConf Iceland, presenting about one laptop per child in general, history and outcomes. But I'm going to focus on new material for everyone in the laptop project community, which is like learning to code and things like that. And when I've been when I went to the project in Iceland, and then actually just last weekend I was in Morocco, most common response is still, we need OLPC. You know, people everywhere in the world are having this issue of how can we supply schools with these computers. And not necessarily the laptops themselves, but maybe that next generation laptop that we just saw. I had not seen that before, or some other kind of technology. And there's many education and technology challenges out there that can be solved with existing tools. And programmers kind of have a need to build new things and find unsolved problems. And that's what I want to get into, is no one really knows the right way to teach code, because we haven't been teaching it for very long. We haven't been teaching it to the general population for very long. It used to be that someone went to a hacker group, or they went to college for computer science, or their parents taught it to them, but we don't know how to teach the general public in a way that everyone has an equal opportunity to say, hey, I'm interested in coding, I want to dig deeper, this is what I want to build, how do I do it? So these are the programming tools that we all know from the laptops. Turtle Art, which is like this block-based program. eToys, which doesn't seem to get so much play. Scratch, though we had kind of an older version of Scratch at the time that was just based on the computer. And Pippy, which was used to teach Python. And it's interesting to see, the programming languages that are out there now that I'm going to talk about. There's block languages similar to Turtle Art, where you have the different blocks of code. Game-based coding. There's interesting games that people can do, makers and robots. And also this interesting concept that I'm kind of trying to get into right now called reactive and literate programming. And so what we've seen in our own things is Turtle Art is now Turtle Art JS. That got moved to be a web app that any computer can use. The Scratch team has kind of removed everything onto be like an online app that you can't really easily redeploy if you have an offline server. And when the laptops came out, people were interested in Python. A lot of people throughout the tech community were promoting it. A lot of colleges were changing their computer science programs from whatever language they used before, Java, C++, and everyone was focusing on Python. And now that seems like a really unusual choice. Python is sort of split, and there's this very powerful JavaScript community. Everyone's using JS now. Adam was asking that question about will everyone be speaking the same language in 500 years? And I don't know that, but we'll all be writing in JavaScript. No one will be writing any other languages. Anyway, so why is everything being put online? I thought, one laptop per child, we focused a lot on being offline, being resilient. But the web moved really fast. It used to be that it was really hard in a lot of the schools that we were deploying to even to get a mobile phone signal, or especially not a mobile 3G signal. And now it's moving really fast. Khan Academy for years has been showing that a lot of these countries, people are able to have access to video and they're studying with it. And it's very important for them to study. They're using what limited access they have to learn through this method. So it turns out there's many different ways, including just leveraging the internet, that we could be educating people around the world. And Turtle Art is one thing. This is a similar project through code.org, where they're using blocks. And I chose this screenshot for two reasons. One of them is using Frozen. It's using Elsa. Instead of a turtle, you have a Disney character that kids are already familiar with and really interested in. And I think there are some purists out there who will say, oh, I don't want an Elsa or an R2-D2 in my kids' curriculum. But this is, more kids are learning how to use programming and think about programming with this than have learned in all the decades of using turtles. So it's an interesting concept and something we should be, thinking about when we choose programs. Another thing I really like about this is because it's blocks, they were able to translate the keywords. So this is an Arabic programming environment, and you'll even notice the blocks open up so that they go right to left. So this is actually really interesting. They went through the trouble of designing it so it is a native Arabic programming environment. But it's available in several languages, including English and things like that. But this is just an idea of what's out there and who's supporting it. I think actually Cartoon Network Arabic was a major sponsor of getting this out there. And there are other, not just for kids, but other local programming languages. This is one called Kalb, which is an Arabic one. And then it's based on Lisp. If we have any programmers out there who are interested in that. And then this other one came out this summer called Potaka. It's in Bengali for Bangladesh. And so there's these different languages that people are writing, people can write in their own native language. I was going to ask Jennifer about that in case maybe some of these First Nations languages would be interesting to have a programming language of their own. But that's not the direction that the big players are going. Like Scratch, I think, has done some translation, but right now they're saying, we need to redesign for native apps. We need to think about how is it going to work on a tablet. So my understanding is that Scratch and Google are developing a new form of blocks that's going to be more designed around touch screens in this particular way. I don't really know what that is. I don't think anyone's done their hands on it yet outside of their team. But there's some interesting articles out there if you're interested on where Scratch is going to be going in the next couple of years. Looking beyond blocks, though, they're very big. And I think a good sign about them is that kids and parents are seeking them out on their own. That's not the solution for everything. Not every kid learns independently. But if you meet kids and parents who just found it and were using it for fun and were interested in learning that way, that's a good indicator that it's not going to suck if you bring it into your classroom. Because people, given their own choice, are seeking it out, and a lot of people are agreeing that this is a good way to teach it to kids. But the world needs options. Every learning situation is different. Every school is different. Maybe your school doesn't provide coding education and you're teaching your kid at home. Or maybe your kid really just is using the screen all the time for YouTube and Twitter. I don't know if any of you have volunteered with like a high school group that's allowed to have FaceTime and iPhones and stuff while they're doing the project. But people are on FaceTime like 80% of the time. So maybe you're saying, look, I don't want to have a coding environment where like 80% of the time they're tabbing over and talking to their friends. So we need to think about different, more engaging ways, or things that they're playing a game and the programming just kind of like slips in there as an idea. So this is one called Code Combat that I think I mentioned a few years ago when it came out. But it's actually like a role-playing game where you write these, they call them spells, but it's JavaScript. You write some programming on the side there, and it commands the little players to go and do different things. And it gives you some hints about what you can do and what you can say in the game. So this is sort of a more interesting way that you could be teaching it. And actually a big development that happened this summer, I hope many of you have heard about this, Apple released this tool called Swift Playgrounds for the iPad. And you can write in a programming language on the iPad. It'll suggest programming keywords that you can use. And Apple's going to teach classes in their Apple stores for kids to learn how to use this language. So you might in the future run into people who learned how to code with something like this, just this little interesting game. They'll say, yeah, I was at the Apple store when I was a kid, and they explain this. It's interesting to think what kids might be engaged by something like this and take this in a different direction to learn how to code. I think a couple of years ago, you guys saw a presentation from these guys, BoutiaBot, is that right?
Yep.
Great. So there's these different robots out there for teaching kids how to code. BoutiaBot, I think, was made to be very low cost. You know, you get added onto your laptop and you're able to do a lot of great stuff. There was an interesting project a few years ago called the $10 robot. You know, like we have the $100 laptop, they have the $10 robot. And this is one of the robots. I don't know that they got it exactly to $10, but maybe at scale you could do that. And it doesn't do a whole lot, but kids can make it and learn about electronics and maybe write programming to a very simple chip to make it do different patterns. And so that might get programming to be less of like a mathematical game. Like you wouldn't have kids hang out and learn how to do spreadsheets, right? They get really bored doing spreadsheets. And for a lot of kids, coding looks like it's going to be at least that bad or worse or more boring. You know, so having something like a robot that you could play around with and have it scale for the kids in your class might be really interesting. There's some different ideas about making physical coding blocks, taking ideas that work in Scratch and turning them into actual blocks. Like there's little bits, which is a little bit different. The main issue with this is that it costs about $10 per block to make a kit. So this kit here, where you could make maybe like 1 or 2 interesting circuits, would cost you like $80, $100. And so that's not very, it's an interesting concept, but I don't think that it's going to be how we teach kids how to code. It's a very expensive concept. There's this game. Has anyone seen this game, Robot Turtles? Okay, so my mom teaches some kind of class in elementary school. Like she's supposed to teach like English as foreign language class, but then she convinced them to teach programming to different people throughout the school. And one thing that some parents have and suggested to her, and she started using, is this game called Robot Turtles, where there's no computer at all, but you write instructions for the turtles. It's basically a board game version of turtle art. And really interesting. Their parents and kids are using it. They're not thinking about it as programming, but it teaches you to build up these certain patterns and instructions. I also saw this game, but we don't have enough time to go into it. Similar concept. Board game that teaches kids how to think of how to make these patterns for coding. There's another concept out there that is sort of being developed and having a lot of new recent developments called reactive programming. And the idea with reactive programming is, you know, you do have to write code with actual text and functions and things, but as you're writing it, they want to be able to show you visually what are the consequences of what you're writing. So if you're changing a number, if something's going to change over time, you're going to have some ability to see what you've just done how that affects things and how you could change it to do something else. So you'll never be like, okay, I'm going to write the program and see what happens. Instead, every single keyword and number and line of code, you should be able to see what that is doing in your space. And so this was really pioneered by Brett Victor, who has a really interesting essay online for 4 years now. It's been really good. And people are trying to catch up. So Khan Academy has something slightly similar. And then there's this new environment out in the past couple weeks called Eve, EVE. And it's using this reactive programming. This is something where you can make Flappy Bird using Eve programming language. But it's also using something called literate programming. Like, this is not the documentation or a website that explains how you use Eve. This is a program in Eve where you're allowed to just write text that explains what you're doing and what you're about to write, and then you embed code within it. So literate programming is this idea that has been around for many, many years, probably longer than I've been alive. We can be really honest here. But it's coming back in a big way with Eve because people can write these really interesting web pages where the code just happens to be there, and when you change the code, you see immediately what happens. So that would be really interesting if you could make a coding textbook in this environment. But this just came out, so no one's really sure how good is it, what is it useful for. Risk factors. I've suggested a bunch of different projects. Not all of them require computers, but if you do it and you use JavaScript, because I've been saying people have been moving towards JavaScript, and that's how we should be teaching. So there's some risk factors there in investing in JavaScript, investing in learning how to code using the web. One factor is that maybe JavaScript will be replaced by some other language, because Python used to be really big. But JavaScript has been pretty solid, and I think it'll be supported for a long time, even if something new shows up. One risk is that JavaScript could divide into several incomprehensible, warring factions. Do you have any JavaScript programmers there?
Yeah.
Yeah. This is an inside joke for the JavaScript programmers. Of course, it's already dividing into several factions right now. And another risk is that machine learning could redefine programming, both what we write and how we write it. And this is really like some weird X-Files thing. I don't know what I'm talking about exactly. But in OpenStreetMap, we always used to say that people needed to look at the satellite images and come up with really good interpretations of what was going on. And in the past year, I think it's safe to say, in the past year, this has really turned around. Like some people at Facebook, some people in the other OpenStreetMap community said, oh, let's just make a computer program that does like machine learning, artificial intelligence, just for like error correction. That's how they got it in. They started saying they're going to do error correction. And now it turns out it's much, much better than people at identifying buildings. Like, it turns out that really it was kind of a mistake for us to have people making maps, because the robots are really good at it. And that's something that we didn't really expect. So I'm thinking there's a certain thing that maybe the kind of programs that we write now and teach kids how to write could change the nature of what we actually want programmers to write. But I still think that kind of mathematical and logical thinking about programming is still extremely valuable. So keep teaching kids how to code, even if the robots are going to get better. There's still like a value to having that kind of mathematical thinking. I'm going to briefly mention that I don't know if you can see, this kid is wearing a little star clipped onto his outfit. This is something called Starling. It is a wearable microphone that counts the number of words that your kid hears every day. I have one of these. It's really cool and very subtle. You just kind of clip it on somewhere. It doesn't record all of your conversations. It's not creepy like that. But instead, it's a different kind of creepy where the kids get really attached to having this microphone attached to them. And it changes parents' behavior too. This is all around this larger concept of how kids learn and vocabulary, which I don't have time to get into because I do want there to be time for questions. But I could totally see a whole bunch of education wearables being a future thing. Conclusions. I think that for existing education problems, you want to use trusted technology that's already out there. You don't want to build everything yourself. Programming is interesting enough and unknown enough that it still makes sense for people to be researching new environments or building a new environment to try teaching kid how to code. And I don't really mean to say, I don't have any education about education in philosophy. I don't know exactly how a kid should be learning how to code. But these different options out there, I think, just should be promoted and evaluated based on, do they teach kids math and computation thinking? You know, they don't even need to use a computer, apparently. There are these different board games that are out there and people are trying out. We don't know the result of all this, but I think they're all really interesting initiatives. And if one of them sounds really interesting, I'd be happy to talk to you and see if you can try it yourself. So yeah, that's everything that I have. I'll turn it over to you guys for questions.
Thank you. I have a question. Yesterday we were talking about using the XO for design, specifically font editing, but we're also talking about programming on the XO and how because you have a terminal, that's all you need.
Right.
You know, you showed us a lot of stuff, but kind of thinking about the principles of like what's behind sugar, like what's kind of immediate steps that we could take to make the XO like a better platform for programming.
Well, I mean, the terminal is a bit scary for anyone who's not familiar with it. Like, you want to show, I think there's this theory, I don't know that it's true, but there's this prevalent theory that when you're teaching kids how to code, you don't want them to think it's like all the hacker movies and they have to, you know, get the green text and things like that. So I'm a little bit cautious about saying, oh, you can teach kids, you know, you could very well teach kids how to do Python on the terminal because it's there, or do bash scripting. I like the idea of code.org having this system where they have the different blocks. And I mean, TurtleArt.js is out there as a blocks thing. Code Combat is on the web, but as far as I know, the laptop project web browser probably wouldn't be able to handle it. You know, the laptops do not have a lot of RAM. They don't have a very modern browser last time that I was using it. So there's a significant risk that a lot of these newer game-based programs would be really interesting for kids, but not work very well on the laptops. But even Google Images doesn't work very well on the laptops anymore. And then I would say the same thing about the Khan Academy CS environment. I haven't seen someone try it on the laptop yet. Maybe it's better than I'm thinking. But it seems if you were going to pick out a web-based tool for kids, I think you would go with the Khan Academy tool or one of these code.org block languages. And if you're offline, maybe you could run one of these environments on an offline server. I mean, I don't know. It depends on each case what each school is able to do.
Hi, Nick. This is Tony Anderson.
Oh, hey.
Hi. You made a list of the properties, but when you were talking about these different coding situations, it seemed to me you were focusing on the kids want something that immediately reacts to their input.
Mm-hmm.
And the other was to avoid text programming, with the possible exception of JavaScript, which is a mess.
Oh, it definitely is, for sure. I'm not, English is a mess too, but it keeps winning, so.
But, you know, that's in the professional marketplace.
Mm-hmm.
But from teaching programming, I don't know why you couldn't teach programming in Fortran. You certainly could teach it in Scheme. And Python, the nice thing about teaching a language like Python is it is not changing. It's stable. So this issue about warring factions and what's coming next, I don't know, when I was a professional programmer, the human resources people would advertise a programmer that had 5 years of Go programming experience. Now the language is only 2 years old, but nonetheless, right? But the point is,
Right.
a programmer can learn a new programming language in a matter of weeks. It's learning the basic idea of how to do programming that's really the essence.
Yeah, I think this is a good point. Actually, you should check out, I have a Fortran project. How did I not send this to you? I have to send you my Fortran project. But I would be nervous about teaching kids Fortran after having tried it myself. With Python, I think we had some success. Python is in the sciences. I think that there's a lot of interesting applications there. But now there's this Python 2, Python 3 division. I don't want to overstate it. You could still teach kids Python however you wanted. But it's sort of fading in the sense that, you know, how are when we build these tools, we're building them in the browser. And when kids are consuming media, they're doing in the browser. And Python, you know, is useful as a server or as a scripting tool or as an application. But if so much stuff is happening in the browser, there's sort of this theory around the language that we teach should be JavaScript as well. And that's not the case in all these things. Like Swift is a iOS specific language. I think they're building it out to be used other places. But I guess your question is like, is JavaScript all that valuable, or should you just choose the best language for teaching kids how to code? Right? Like, I mean, blocks are chosen not because we think that there's a generation of kids that are going to learn how to code in blocks in the future, but because it just makes programming make more sense. And yeah, sorry, I'm kind of going on a tangent. What was your?
I'm just thinking, I'm trying to make a slightly different point. I do see the value of kids learning to program in a block language to start with, because that gets them out of the syntax issue of learning how.
So you're asking what's next? What's that next after this?
But what we don't have today in Sugar is a transition point or a way to go from the blocks programming to text programming. But if you're going to be a professional programmer, or you're going to do any really serious programming, you're going to have to get into text programming. Now, whether it's, I don't think it matters whether it's Python or JavaScript or what language you learn to program in. And it certainly doesn't matter between Python 2.7 and 3.4. I think you probably don't want to go back to basic. But right on Sugar, you could program in C, you could program in C++, you could program in Fortran, you can program in Ada, because we have GCC, right?
I guess what I'm circling back to is that, like, where do you graduate after blocks? And we have the Pippy interpreter, and I tried to understand, you know, Pippy interpreter can do some interesting things. You can just mess around with the code and have some interesting things happen. But in terms of creating, like, let's say a user interface, using Pygame or using PyGTK, it's possible, but it's very difficult for kids to create something visual. Now, if they're in like a science class and you just want to predict like a trajectory of a ballistic missile or something like that, it would be really useful to have Python, I think, for kids to understand how that's going. I think in terms of visual, like, how can we make something how can the kids make something that they can customize that's their own visual environment? It turns out HTML is really good, and then they want to do something with HTML. And so we can really only choose JavaScript at that point. And then they want to be able to share it with their friends on the web. So I think that's one of the reasons that Mozilla has been using HTML and JavaScript almost exclusively to teach kids, is because it lets them make something visual very quickly. Like in a day, you can do like a Coder Dojo event and teach some kids how to make something. And then they get a link that they can use to share to their friends on the web. Now, there are ways that Python can work on the web, not like officially sanctioned ways. There are ways that you can get people to run Python on the web. And I think it would be really interesting to see more alternatives. It adds that extra complexity to what people are creating when they create this coding environment.
Yeah, I would just argue that I could make something animated, visual, just as fast in Python as you could do in HTML. And it's not arguing about the languages. I say, I don't really think the language is so important. I think for a kid learning JavaScript, that's going to be more difficult than Python just because of the syntactical sugar that JavaScript has. But kids can learn it. But the other thing about HTML is that in order to use program in HTML, you need to do two things. You need to learn HTML to get the static image. Then you need to learn JavaScript in order to make it move. So it's really, you have to get them into two levels of programming where you can do that in one in Python. So I don't know.
Yeah, I think we all have kind of like a love-hate relationship with how the web currently works. And I do hope that programming radically changes. That's one of the, I don't know exactly how it's going to go. But one of these systems, I'm just in general interested in these different systems for teaching. But yeah, do we have other questions there?
Yeah. Manny, we're kind of out of time. We got to take a break.
No. Do you have like a quick question? You were waving.
Well, I just wanted to make a comment. I am Sofana from Chicago. Hi. I just think that using blocks or using code, I mean, one doesn't exclude the other. I mean, because I think that pedagogically, using blocks is a really good way to start. We are working on this and figure out what and our kids are first using blocks and art and programming, to understand the logic of programming. And then those kids that already know the logic and can program in blocks, they are working with code because, of course, you won't be able to become a professional programmer just programming blocks. But I think that pedagogically, using blocks is really important and useful.
Great.
Okay, yeah, I think we are running out of time, so I'll leave. But Adam has my contact information, so you can bug Adam as my contact person.
Okay. Thank you, Nick.
Okay. All right, thank you.